So in this video, we're going to be doing an increasing annuity example, a decreasing annuity example, and an increasing perpetuity example. The first example here comes from the textbook. 8.09 says that we have an annuity that consists of 75 payments starting at 200, and then it increases by 4 per year every year after. They give you the annual effective interest rate of 8% and asks you to find the present value of the annuity. So we have an increasing annuity here, but notice that the starting payment amount is different than the increase amount. So really what we want to do here is split this up into two annuities. We can split it up into a level annuity of 196, and the reason why we use 196 is because, remember, for an increasing annuity to use the formula, we want that first payment to be the same as the increase amount. So since the increase amount is 4, we take 4 off that first payment, make it 196, make it level, and then we can follow that with an increasing annuity that starts at 4 and increases by 4 for each payment. Using the formulas, we have our present value is 196, A angle 75, here's the level annuity part, and then 4 I angle 75, there's the increasing annuity part. Using our calculators, we get 2442 and change for the level annuity, 661 and change for the increasing annuity, for a total of 3103.60. This is a very calculator active problem to get these two values. You may want to make sure that you use your calculators on these because they're your friends. Even though you're expected to know the formulas, being able to use the calculators will save you a lot of time on exam FM. Here's a decreasing annuity example. This is 8.26 in your book. We're going to have an annuity that makes payments of 30 for the first 20 years, and then payments that decrease by 1 for each year for 29 years. So the annual effective interest rate in this problem given to you is 9%, and they want you to calculate the present value again. So notice this is a decreasing annuity, but the decreasing annuity follows an annuity-immediate. So we've got this level annuity-immediate for 20 payments of 30, and then we're going to immediately follow by a decreasing annuity-immediate with 29 payments starting at 29 and ending with 1. So that's good because our ending payment and the decrease amount is the same. So we can just apply the decreasing annuity formula directly. However, notice that if we calculate the present value of the decreasing annuity part just using the formula, that's only going to take us to time 20 because remember, it only steps back one payment period from the first payment. That first payment at 29 happens at year 21, so if you use the present value of the decreasing annuity formula, we're going to get the value at time 20. So we're going to have to step that back all the way back to time 0 by multiplying by our v to the 20th, our discount factor. So putting everything together, our present value here is 30 A angle 20. There's our level part. We've got the DA angle 29. Here's our decreasing annuity part for 29 payments, decreasing by 1. And then the last payment amount is 1. Here's the V to the 20th to step us back from time 20 to time 0. Using our calculator again, these are the various values. 273 and change is the value of your level annuity immediate. The 208 and change is just the decreasing annuity part here. The 0.1784 is our V to the 20th piece. Putting that all together, we get a present value of 311.13. Finally, here's a perpetuity example, an increasing perpetuity example. This is 8.20 in your book. It's a perpetuity due in this case, pays $275 now, and each payment gets bigger than the previous one by 25. So this is where we have an increasing perpetuity. This one tells you the present value and asks you to calculate the interest rate. All right, so again, we have an increasing perpetuity, but again, the first payment is not the same as the increase. So we break it up into two pieces, a level perpetuity due with payments at $250, and an increasing perpetuity due, payments starting at 25, increasing by 25. Formulaically, we have present value is 250 A double dot infinity. That's our present value of the level perpetuity. And then 25 IA double dot infinity. That is our present value of the increasing perpetuity. These are perpetuity dues, so our formulas involve the discount rate. So we were given that our present value is 21,590. Present value of the level perpetuity due is 250 over D. present value of the increasing perpetuity due, it's to 25 over d squared. Let's clear the fractions and divide by 5 and move everything to one side. We have a quadratic. We got this quadratic to solve. Unfortunately, that doesn't factor, so we get to use the quadratic formula. And we get two values for d. One is 0.4043 and the other one's negative. Now, again, we can't have negative discount rates, so we must want to use the 0.4043. This problem didn't ask us for the d, this problem asked us for I. So putting in I over I plus 1 for d, we can solve for I and get I has to be 4.2%.